Okay, so in the previous video, we covered factors, right? So if you had a random term, let's say, for example, 11x, and we had to write down the factors of 11x. So in this case, it would be 11 and x, 1 and 11x. All right, so if you haven't watched that video yet, or if you don't understand why these would be the factors of 11x, I strongly encourage you to stop this video now, go back and watch the factors video first, because it's going to make everything we cover from this point on making a whole lot more sense. All right, so let's just get straight into factorizing. So let's look at our first example. Let's say the question asks us, and you often see this in exams and textbooks, it'll say factorize fully, right? It just means factorize it as much as possible. All right, don't worry about that too much right now. Let's just have a look at our first question. Let's say we have 2x plus 2y. Okay, so we want to factorize this. So what we do is we can see this expression here has two separate terms that have been added together. We don't know the value of either term, right? There's an x in the first term, meaning if we don't know what x is, we certainly don't know the value of two lots of x, right? That's a big question mark. And same with y. Y is some other unknown number. So if you've got two lots of y, you don't know what that value is either. How do we factorize this thing when we don't know what either of the numbers actually are? Well, we can still do it. All we need to do is look for common factors. So if you look at the first term, 2x, you see we've got factors of 2 and x, right? And if you look at the second term, 2y, you have factors of 2 and y. Is there a common factor? Common means it's in both. Is there a factor that belongs to both of them? And of course, the answer is yes. That factor is 2. What we can do is we can take that 2 out the front, and then in the brackets, you write what you're left over with. So if we're taking that 2 out, the 2 is gone from both terms. You're left with a x from the first term. There was a plus in the middle. And you're left with a y from the second term. So your answer will be 2. This is how it actually reads. There's a 2 outside of x plus y. That would actually be your answer. All right, let's see it again, because, obviously seeing just one question alone isn't enough, right? Things will probably still be a little bit confusing for you. So let's look at another one. So we want to factorize fully. So this time I'll give you the question. Let's say we have 5 lots of A minus 5 lots of B. So we want to factorize this. Again, we want to look for the common factors. A lot of you might be thinking already the common factor is 5 and you want to go straight to the final answer. You absolutely can do that. But I'm going to break it down just for those people that maybe have no idea what's going on. 5a is 5 times a. 5b is 5 times b. I've split these two terms up into their factors. Looking at them, we find the common factor, the factor that belongs to both. And that is, of course, the number 5. 5 is a common factor. You take that 5 out the front, there it is, and in the brackets write what you're left over with. We're left over with an A from the first term. This time we have a minus in the middle, so bring the minus through to the middle, and then you're left over with B from the second term. And that there again is the question done. Now, sometimes they do get a little bit trickier, no doubt, and you'll see that in the second part of the worksheet that you'll go through. Let's have a look at this next one. It'll look something like this. Let's say we have 4p as like a random pronumeral. So we've got 4 lots of p plus 12. All right, so we want to factorize this expression here. So we want to think about 4p, 12, what's the common factor? And you know what? If you're okay with your times tables, a lot of you might be leaning towards the number 4 already, which is great because that is our highest common factor we can take out. But let's look at 4p firstly. What are two factors of 4p? Well, 4p could be broken up into 4 times p. 12, can we get the number 4 in? Yes, we can. 12 is actually the same as 4 times 3. So what we've done is we've rewritten both terms into their factors, 4 and p and 4 and 3. And of course, just like we did with the previous 2 examples, we're going to take that common factor, which is 4, out the front. And we're left with a p from the first term, a plus is in the middle. From the second term, that 4's been taken out, and we're left with a 3 in this case. And that there would be your answer to that final example. What I might do is I might just give you one more bonus example just so you can see that again. It's really crucial that you know your times tables for these questions. So if you're really bad at your times tables, it's definitely something you're going to have to work on. Calculators don't help you a whole lot with this. They certainly could help a little bit, but just knowing your times tables cannot be replaced. Let's say we have 5x minus, let's go 30. Okay, so we want to factorize this expression here. Okay, so 5x and 30, what sort of times table can we use for both of these? Certainly 5 and 30, they both belong to the 5 times tables. So let's use that. 5x is 5 times x. 30 is 5 times, you have to think, 5 times what equals 30? And it's 6. 6 is a 30. We've split it up into its factors. We've got this common factor that belongs to both. We can take that common factor out the front, and of course you'll be left with an x. This time we had a minus in the middle, and you'd be left with, in the second term, you take that 5 away, because we've already taken it out the front, you're left with a 6, and that will be your final answer. If you attempted to split up the 30, using, for example, 2 and 15, although that's true, right? 30 has lots of different factors. Unfortunately, 2 and 15, neither of those factors are common with the first term of 5 and x. So what you need to do is, it's not a matter of just finding a set of factors and then you're done. You actually have to find the common factor, right? So that's where you have to look at both terms and say, what do they have in common? They both belong to the 5 times tables. That's how I knew I had to use the 5 times tables with the 30. Anyway, that's it there. Hopefully that makes sense. Have a go at the worksheet. Of course, if you have any questions, please comment. I will read them, or you can send me an email directly. All right, thank you and goodbye.